Chapter 14, Section 4, Simple Machines. We've talked about work, power, machines, and mechanical advantage, but today we're going to talk specifically about different types of simple machines. So the types that we're going to go over are the lever or lever, the wheel and axle, the inclined plane, the wedge, the screw, and the pulley. So starting out with the lever or a lever, either pronunciation is correct. It's a rigid bar that is free to move around a fixed point. Now this fixed point can be on either end or in the middle. So when I say a fixed point, I really mean a fulcrum. That's that pivot point for the lever or for any kind of bar. So for example, here for the seesaw, you have the fulcrum or the pivot point is in the middle, and then you have two ends that are open for movement. Your input arm is the distance between the input force and the fulcrum. The output arm is the distance between the output force and the fulcrum. So it all depends on where the fulcrum is as to how much mechanical advantage you get for that. Now there are three different classes of levers. The first class are ones that have a pivot point in the middle. So a seesaw, a pair of scissors, tongs, those type of things. The second class of levers is where the pivot point is farthest from you, so it's at the end that's farthest away from you. So a wheelbarrow you're picking up and you're able to move your end, but it's pivoted to the ground. That's your pivot point. And then you have third class levers such as baseball bats, hockey sticks, golf clubs, those things where your hands are the pivot point. It's free to swing, but your hands are the part that's keeping it fixed. The second type is wheel and axle. It's any simple machine that consists of two discs or cylinders. Each one will be a different size, and they will rotate. And in this case, your IMA will be the radius, not the diameter, but the radius of those cylinders. We also have inclined planes, which is a slanted surface along a force moves an object to a different elevation. So think about a ramp or going up a hill. We're moving to a different elevation, higher or lower, along a slanted surface. IMA in this, and we looked at IMA examples for inclined planes, it's the distance along the plane divided by the change in height. So here's an example. A wedge is another type of simple machine. It's a V-shaped object, and the sides are literally two inclined planes that slope toward each other. A thin wedge of a specific length has a greater IMA than one that's thick of the same length. So a thinner wedge has greater advantage than one that's thick. So think about chopping wood with an axe. You want one that's really thin on the part that's hitting the wood and thicker at the back end. A screw is another type of simple machine. It's an inclined plane that's wrapped around a cylinder. The threads that are closer together have a greater IMA, and then those that are farther apart have a smaller IMA. And here's an example. And then the last type is a pulley. It consists of a rope or could be a wire that fits into a groove in a wheel. And your IMA is equal to the number of rope sections that support the load being lifted. So, for example, in this case, we have one rope section, and it's split into two, so you can either pull it straight up like this one, or if you have it hooked as the second one, you can actually, instead of just pulling straight up, you can pull out as well. So this would be, IMA would be equal to these two sections. And there are a couple of different types of pulleys. We have the fixed, which is the first one that I showed you. So it only changes your direction of the force. And then you have the movable, which changes the direction and the size. Once we start combining those and have more than one pulley, you have what's known as a pulley system, and that's when you have both fixed and movable pulleys working together. Last thing is compound machines. It's a combination of two or more simple machines that operate together as a whole system. And that's it for chapter 14.